Good morning, good afternoon, and good evening, everyone. Thanks a lot for joining. I'm Vin, and I welcome you to the Db2 webinar session. Today is our fourth session in the 8-session webinar series. I hope you guys have enjoyed the first 3 sessions and found them useful. Today, we'll be looking at the developer features that are coming out with Db2 11.5.4. Before we get into the session itself, I wanted to do some housekeeping items taken care of. So first thing, the session is being recorded, and this will be made available with the July newsletter. I repeat, the previous sessions, the current session, and the upcoming sessions, all of them will be recorded, and they'll be made available as a consolidated list with the upcoming monthly newsletter. We will have 3 poll questions that will be coming up in the presentation. All the attendees will be on mute so that there is no disturbance due to the background noises. For Q&A, we have 5 panelists that will be available to answer your questions. So please type in your questions and send it to all the panelists. Please do not send the questions in the chat or in the personal chat, as we are not monitoring that. Also, in the end, as time permits, for a couple of minutes, we will be reading out some of the questions and answering those verbally. This is a sample stream, just to make it easy for you, that you should be seeing right now. If you don't have the polling or the Q&A tab, it should be available by clicking on the button that has 3 dots as shown by the red box highlighted as number 1. Once you open that 3-dotted button, you should see polling and Q&A sections. And when you click on them, the polling and the Q&A sections will appear on the right-hand side so you can interact with them. With that, let me begin today's session. So the speakers today are obviously me, as I am the offering manager for Db2 REST service. I also have 2 magicians joining me today. One is Dan Snoddy, who is the development lead for Db2 REST and Db2 Graph, and he'll be showing us the live demo for Db2 REST service. I also have Tom Kalinko, who is a software developer in our Db2 Research AI Hub, and he will be talking about an exciting app that you can build using the Db2 REST service. And I'm not going to share much details on that and want to keep it exciting since this demo is really breathtaking. So the content that I've laid out today is from mindset of a developer. When I used to be a software developer myself, it was primarily about that if you are given a problem and you have to solve it, the first thing that you look at is what are the tools available for me to accelerate my problem-solving journey. So for that reason, the first thing I want to cover are the drivers that are available in the Db2 ecosystem that can help you accelerate your problem-solving journey and your developer journey. How I have laid out the content for drivers is I'm going to cover specific drivers, then the frameworks that are supported and ORMs, and then I'm going to go just a little bit into what you can expect in the future with the drivers roadmap. So this slide talks about the specific drivers, and I'm happy to share that with the 11.5.4 release time, we will be supporting language. In terms of .NET, 3.14 is going to be supported. .NET is having refreshed to support some incremental features that came out with it. And our team has also tested .NET Core drivers on AWS and Azure Db2 deployments. Python remains a high priority for us, and for that reason, we will be supporting Python 3.8 with the upcoming release as well. The Ruby driver came as a requirement from a couple of you, and we brought it up on the roadmap, and with 11.5.4, actually previous month itself, it was released in the marketplace, and you can build your apps using Ruby and also Rails that I'm going to talk about in the next slide. Currently, our support for Node.js remains at 13.x version. For 14.x, I'll cover that in the roadmap slide. For PHP, we currently support 7.4, which is the latest in the market. The Go driver has also been refreshed, and our previous support was at 1.13, and now we are supporting Go 1.14. In terms of application frameworks and ORMs, our current roadmap is to support Django by September 2020. We did have plans to support it by 11.5.4 release, but due to the pandemic, we had to push it out a little bit. Rails did come out in May with Ruby itself in May, so it's available for your use. And .NET Entity Framework will be supported with the .NET 3.14 release by end of this month. In terms of ORMs, we currently support SQLite at version 5.21.5, which is pretty latest, and SQL Alchemy version 1.3.x. Want to spend a little bit about the roadmap and what we can expect in the future about the drivers. So I want to start by saying that our policy is to support LTS supported version of languages. And that may introduce a little bit of delay on supporting the latest and the greatest version of languages. However, it is important to support LTS versions. So if you build an application with those versions, you can be rest assured that they'll be supported for a couple of years in the future. With that in mind, Django 3.2 LTS version will be available in October as planned by the Django community. And as soon as it is available, we'll put it on the roadmap to get it supported as soon as possible. Similar is the case with Node.js. Node.js 14 LTS version will be available in a similar time frame of October. And for that reason, we'll start putting it on the roadmap as soon as it becomes available. .NET Core 5 will be available in the market itself in the October-November timeframe, and we'll make it available. We'll put it on the roadmap and most probably planned it to make it available by December 20. Similar is the case with .NET Entity Framework 6.4, which is planned for Q4 2020. In terms of JDBC 4.3, support is planned for Q4 2020. And OpenJDK 13 is currently planned for September 2020. And OpenJDK 14 is planned for December 2020. The VS Code extension has become a high priority for all of us as it has been widely adopted by the community. Last year, we put out an MVP, which was very pretty, and for that reason, you can expect various features being rolled out throughout this year. With that, our first poll question is up. If you can please participate and submit the answer, that will help us immensely. I see some of the comments that there is some audio issue, so I apologize for any technical difficulties. At this point, I'm not sure if the network will allow me to fix that issue, but the session is being recorded. So when the session recording is available, please go through it. I apologize for any technical difficulties. I think we have last 15 seconds to complete the poll. Okay, Shruti, is our poll complete? Shruti, are you there?
Yes, we were just waiting for the last few people to hit submit, but
Okay.
we're done now.
Okay, so you can also see the poll results. We've shared it with you, so thanks a lot. And let's move on to the remaining part of the presentation. So the next item I want to talk about is something that we are releasing for the first time ever in the DB2 product. That will help you bring to the database. The reason to have DB2 right now is because based on the Stack Overflow Survey 2018, 2019, and 2020, Python has become the de facto most popular language among developers. Also, if you look at specifically the data analytics and data science community, Python is the #1 language of choice among that community. So for that reason, we had to come up with a way to bridge the gap between Python and the database. And Python UDF intends to do that exactly. Let me give you an overview of the Python UDF. So on the right-hand side, you see the 3 steps that are required to basically implement and use the Python UDF. #1, you have to create your Python script, which will contain your logic, and that's where your Python skills will be used. Step 2 is registering that Python UDF. Step 2 is registering that Python UDF in the DB2 as a function or as a user-defined function. And step 3 is actually using that UDF for your workloads. I want to specify that these UDFs can be custom created and are not limited to any predefined functionality that comes out of the box. So it is up to you to build the UDFs based on your own requirements. There are certain restrictions, or I would say requirements, to make it executable. #1 is that the Python script must be having the extension of .py, and in your DB2 environment, you have to specify your Python runtime. The current support for Python UDF is for Python version 3 language. The functionality that is supported are scalar functions, table functions, and aggregate functions. The OS supported is Linux only right now. The platform are supported both x86 and Power. So let's look a little bit deeper in the Python UDF runtime architecture. And the reason for that is because I've come across a few customer discussions where they would like to understand how the Python UDF actually gets executed and implemented. So if you see the figure here and go from left to right, when an end user tries to execute the Python UDF that they have created, it gets submitted to the engine query processing. When the engine query processing figures out that it launches or spawns this FM in turn is our UI script, which is responsible for setting up the required Python environment that will be used to execute your Python logic. The intent to show this is because it is important to note that to implement and execute your Python UDF, it is required to have Python installed on the DB2 servers, because those Python runtimes will be used to execute your Python scripts. In terms of the data exchange, the engine and the Python process exchanges the data using our NZ-compat layer, which makes the data types compatible between the DB2 database and the Python language. And with these stitched together in a specific flow, your Python UDF gets executed. In terms of the use cases based on various discussions among customers and the Python community, The top two use cases that have kind of bubbled up are data manipulation and machine learning. The reason for data manipulation is, as I said, in the data analytics community, Python is the de facto leader in terms of programming. And that's kind of the reason that in your organization, if you have a data engineering team, they might have well been using Python for a couple of years now. And using their scripts to bring that data manipulation logic closer to the database is what the Python UDF will provide. In terms of machine learning, I have a really nice demo that I want to share with all of you, which will explain in detail how the Python UDF can help you bring machine learning closer to your data.
I'd like to show you how to use Python UDF and Db2 to operationalize your AI pipeline. They allow you to integrate your data scientist's work into your production environment. That means you can go seamlessly through the stages: develop, test, deploy, and then run your AI at scale in Db2. Rather than pulling your data out of the warehouse and moving it to your AI workbench, you can move your AI execution into the database to your data. In the recent years, Python has become by far the most popular programming language in the AI space. It offers a rich environment of open source libraries that data scientists love and use for their work. With Python UDF, data scientists can continue to use all this in their favorite development environment and then easily move the execution into Db2. Let's give an example of how this can look like. We have some sample data from a telco customer, and some of these customers have resigned from the contract in the past. So we want to use this data to predict if other customers are likely to resign from their contracts as well. So we have data like how many international calls did they do, how much were their charges, how many time did they spend in the day, the evening, or the night on the phone, stuff like that. As a data scientist, you don't want to use this command line interface to analyze your data. You use something that you can use in an interactive, iterative way to create a model for this prediction. In our case, it's PySpark Notebook, but of course it could be any other IDE, it could be Watson Studio or whatever. So what does the data scientist do? First, we will import some Python libraries. In our case, we want to use sklearn to build a logistic regression model for the prediction. Next, the data is loaded and then explored. We have 17 attributes, do some basic statistics about them, maybe use some visualization to get deeper insight into the attributes, and then start to prepare the data. In our case, it turns out that it doesn't really matter whether the customer had a lot of phone minutes on the day, in the evening, or at night. And therefore, we add an additional column, total minutes, which just adds up all those time values. Then we use an algorithm to do the feature selection. And in the end, it turns out that 6 attributes are really relevant for the prediction. Next, the algorithm is trained. Then we do some fine-tuning of the hyperparameters and optimize the model. Ultimately, we come to a model, do an assessment, and figure out the accuracy. In our case, it's 89%. Not too bad, but not really great yet. But it's good enough to go ahead. And finally, the model is saved into a file, which is then moved over to the Db2 database. Let's see how this is put into production with the Python UDF. I've created a UDF called predicted churn, which takes those attributes that we've identified as features and predicts the churn. So as you can see, runs on the data, and for some of the customers, it indicates that the likelihood is big that those customers might resign from their contract. So let's see what happens under the covers. This is the UDF. It's pretty simple. At the beginning, it imports those Python libraries that we use in the notebook as well, in particular sklearn. It is basically 2 steps. One is preparation of the data, where we set up this additional column, total minutes. And then a second step, doing the prediction, which is simply calling the model prediction. If you get new data or an updated model, it's pretty simple. We just export it, load it up to the Db2, and UDF will use this new model and do the prediction based on the improved model. So to summarize, with Python UDF, data scientists can use the familiar development environment and the Python programming language to do their work. This AI pipeline is extended into Db2, where the resulting analytics procedures can be executed at scale using Python UDF in Db2.
Great. I hope you guys enjoyed the demo. And now let me go into the most awaited section of the presentation for today. So let's get to know the Db2 REST service. Before we get a deeper dive into the Db2 REST service itself, I know most of you are already familiar with what a REST service is and what are the benefits for it, but I kind of tried to make an attempt to share with some of you folks for whom this might be new. So imagine if you're a developer and you're working with your current approach of either JDBC or DBALs. When you're talking to the database, you have a lot of restrictions and coupling of code between you and the database itself. And compared to that, wouldn't it be much nicer if you had the freedom to use any language that you like with supporting HTTP protocol? So that kind of isolation between the developer's code and the DBA's code or the database implementation is kind of what the Db2 REST service can provide. Similarly, in the case of DBAs, which is much more interesting to see, that a DBA is supporting multiple line of businesses, and each of the line of businesses are requesting access to the database. Now, what could happen in that kind of situation is the line of businesses and the SQL writers in those line of businesses can do a lot of things that you don't want them doing with your database. So to isolate your DB server from exposing those kinds of functionalities and only exposing data retrieval and data requesting capabilities are some of the key capabilities that the Db2 REST service can provide. Now, the intention of the slide is not to precisely articulate each and every advantage or disadvantage. However, it was an attempt to explain that why Db2 REST service can be very beneficial in complex environments where you might be well off isolating your developer workloads or persona related items with the DBA related items. Let's look a little bit deeper into the Db2 REST service. So the Db2 REST service is going to be available as a Docker container. It is also going to support not just Db2 11.5, but 11.1. So for our customers who are at 11.1, you might be able to take advantage of Db2 REST service as well. The availability of the container is going to be on IBM Container Registry website. Now, I do want to highlight and point out that we have been putting the Db2 containers on Docker Hub previously. However, our customers themselves requested that their corporate policies did not allow them to use a technology that was not available directly from the vendor who's providing that software. For that reason, we had to move from Docker Hub to our IBM Container Registry website itself and make the containers available there. In terms of REST service, a REST service that is exposed as an endpoint will have a single SQL statement behind it. Now, these statements can be static or dynamic. You can use any language that you like that supports HTTP protocol without having to install Db2 drivers. And I think that's kind of the beneficial point here, that you wouldn't have to spend the hours or even days in case you want to set up a specific driver for Db2. With that, I tried to highlight some of the capabilities that are provided in terms of persona for developers. who can execute the services that are exposed, describe or monitor services, stop a job, for example, in case there's a long-running job, versus the administrator who can create, delete, update a service, monitor the services, and have the privileges to grant and revoke the privilege of a developer or a user to use a specific service. With that, I know that most of you have been waiting for the real life demo, and that brings us to that part. So I'm going to hit start here and pass my presentation to Dan, who's going to show us the live demo for Db2 REST service. Shruti, can you pass the demo, please?
Yes, I just did. Dan, are you able to share now?
I'm just trying, Shruti, 1 second. Okay, can you let me know if you see my screen?
Yeah, we can see your screen.
Okay, perfect. So hi, I'm Dan. As been announced, I am one of the development managers on Db2. My group has been working on Db2 REST as well as Db2 Graph, which you'll see next week if you come to that session. When you get Db2 REST through IBM Cloud Container Registry, you'll also have access to the documentation once it's published, once the product is released at the end of this month, which will show you how to get access to it, how to install it, and how to set it up. It's a fairly simple process. The container itself is not that large, and there's a series of scripts that manage the liveness of the server, that is, to start, stop, request its version, get its current status. I have already installed the container on a Linux machine, so it is running at this point. And what I have up on the screen is one of the endpoints / docs that shows you the built-in documentation for the REST service. So this will be pretty familiar for people if you've gone through these types of APIs before. And the service itself exposes a collection of different endpoints. So I'll walk through these rather quickly here because it's more interesting to actually show execution, and I have a Jupyter notebook where I'll do that for you. So the set of services that are available for you here, or the set of endpoints, basically start with authentication. In order to make any call within the API, you need to authenticate with the REST server and provide host, port, and credentials in order to establish a connection to the server. What authentication gives you back is a token that you can then use on all subsequent calls. There's a series of endpoints, which I'll expand here, that help work with Python. So I'll touch a little bit on that and highlight what you can do with that based on what we just saw with the Python UTFs. There are a few environmental endpoints dealing with permissions, so giving access to people to create services or revoke permission to create services, as well as setting up some metadata and getting log information if you need access to that. But the bulk of the endpoints are related to creating services. So it's important that we understand what a service is. Basically, as been identified, it is an endpoint that you create specific to your application needs, where you identify a name of the service, and you can give it a version number and a description, and the SQL that you want executed when your application wants to invoke a REST call against Db2. There's obviously going to be the typical CRUD stuff, so you can list the services that are available, create a new service, edit, delete, and of course execute the services and see what's going on in the server in terms of which services are currently running in the background. But what I'll do right now is flip over to the Jupyter notebook. The documentation here that you see does show some examples on how to execute each of these calls using curl, Python, and JavaScript. But what I'm going to show is Python, as I mentioned in the Jupyter notebook. So I actually have two notebooks here. I'm not going to show the other one. It's simply called to start things up. It has all my imports in it and some settings to deal with displaying table information. There is no other content in that other notebook related to actually using REST. But what I do have to identify is where I've installed the REST server. So in my case, I have it installed on a Linux machine, and I have to identify where my DB2 is, the port, and what database I'm interested in working with. So I'll just execute this one to get us going. The first thing I need to do, as I mentioned when I quickly showed you the docs, is authenticate with the server. So the only thing that's going to happen actually in this cell is it will prompt me for my username and my password because I didn't hard code that above. So I'll just type in the credential in order to connect to my database, and I will attempt to sign in. And what I've received back is this token. If you look at the Python that I actually have there, I'm saving the token, and then we use that in all the subsequent calls to authenticate me. As Vin mentioned, there's sort of two ways of looking at using the REST service. And the way I've named them here is simply a REST administrator and the application developer, thinking that the person who's going to set up everything in REST is the person that's going to decide which services are available, who has permission to execute those services. And the application developer would be the person who's using these services in their own application development. So the first call that I'll run here is a request to go get the services that have already been created. Excuse my inability to show an empty table in a Jupyter notebook, but this is just indicating that there are actually no services at this point. But what I do have is a demo database set up. If you come to the session next week on Graph, you'll see that it's the same data set that's used in there. And it's basically some patient and claim, the disease service provider information. So presumably I want to create an application that works through this data set, and I need to create a series of REST calls that my application developer can use against this data set. So I'll walk you through a couple of those, and then we'll show what the application developer can do. So one of the tables that you saw there was a claims table. In order to create a service, basically I provide the name of the service. So in this case, I just called it list claims. And the SQL statement that I want to run when this service invoked. So the SQL can be a select, insert, update, or delete. The examples that I'm showing here today, they're all selects, but it's essentially the same thing if I have an insert, update, or delete that I would call. So let's run this REST call, which has now created an endpoint or a new service for me. And the SQL that I run obviously can be as complicated as it needs to be. So I'm just going to run another service right now, or create another service right now that's evaluating the data and looking for which particular claims in my database are above average. And I called this service the claims or claim charges service. So I'll just run that one. And then once we actually see these being invoked, it's possible that I want to look at the details of a specific claim. So in this case, the cell that I have here is showing how you can create a service that takes input. So basically, I can create it with SQL and provide a placeholder and then define what these parameters are. The syntax for setting up parameters is the same that you would use if we were using a stored procedure in Db2. So let's create that service. So presumably, I'm going to go through my my database and know what my application needs are and create services for everything. I'm going to stop with these three. But if we go back at this point now and query the services that are available, you'll see that I now have three services that my application developer can use. And I'll walk through now what the application developer can do. Just like the person who's going to create the services, an application developer obviously needs to know which services are available. So they would make the same call that I just showed a few seconds ago. But seeing the name of a service doesn't really tell me what the inputs and the outputs are. So we have a call that describes the details of what that service is, along with calls to execute the service, retrieve results, monitor what's going on, and stop service if you decide you don't want to continue with it. So I'm going to take the endpoint that I created, which was the claim charges one. So this is the one that had the more complicated looking SQL statement in it. So as an application developer, if I need to make use of that claim charges service, I can run a call that will describe that service for me. Now the data comes back in JSON format, and I simply parse the format and try to display it as the key and the values associated with it. And I put a bit of it into a table just to make it a little bit easier to see. But basically what I can see from this is that the service that someone has created for me does not take any parameters, as we know, because I didn't provide any. And it provides me these columns of data when it's invoked, and I will get that data back in JSON format when I actually execute the service. And then some other details about who created it, when it was last created, and so on. So what I'll do now is actually call the service. So I'm going to run the request. I've identified this as a synchronous call, and I'll talk about that in a second. So let's run that. And what we see is by invoking this REST endpoint, I've got back the data that's associated with that SQL statement that I ran. And we'll take one of these claims. We'll start with the first one just because I remember the number as I scroll. And I'm going to run the claim detail endpoint, which was the one that I created that took input. So the only thing that this cell is going to do is prompt me for that claim ID, which was C4377. So I'll execute that. So this is just an example where I can take input in my REST endpoints to show data, and I can equally go through the same process with inserts, updates, and deletes. But in the case of the select one, which I have now, I have one of those that I created was called list claims, and this one goes against the claims table, which I think has 100,000 records in it. Clearly, I'm not going to want to return 100,000 records in a single fetch. I may also not want to have to consume 100,000 records in a UI, because it wouldn't necessarily make sense in one call. But what I can do for any of the REST endpoints, so this is independent of creating the REST endpoint, it's strictly an execution option, is say that I want to run this asynchronously. And when I run an endpoint asynchronously, what I'm given back is a job ID. And there is an endpoint called monitor, which lets me go and look at all of the jobs that are currently running by me. And I can see the list claim jobs right now is running. I was the executor, and it has a particular status. And when you look through the documentation, which is going to describe what these various statuses are, you'll basically see that there is a status that indicates the job itself has not started yet, that is currently in the phase where it's getting the data, so it's executing the query if it is a query you're running. And the third state indicates that data is available. Once I've exhausted all of the data, I will get an indication that there is no more data available, and the job itself will be removed from the server and no longer accessible once the data has been consumed. So right now I have this sitting here. It's waiting for a call to ask for the data. Now, if I never make that call, the service itself or the server itself will clean things up after a certain amount of time expires, and that is configurable. But I'm going to make the call. What this particular fetch does, or the request for the data against an asynchronous service, lets me input how many rows I want to fetch. Though it is called limit in the API, it is the number of rows I want. So I'm going to run that. So I've received back the first 100 rows of that data set, and I can call this for probably an hour to consume the 100,000 records, which is clearly not an exciting demo. But eventually, I would get an indication that there is no more data available and that the job is complete. I am not going to do that here. So what I will do is invoke the stop. The stop will terminate that rather than waiting for the server to dispose of it itself. Now, I could have run this, sorry, where is it? I could have run this list claims multiple times. Each time I run it, I'm going to get a different job because they're all executing separately, and I would see all the jobs I'm running, no matter what the service is, when I make the monitor job call. So those are basically the commands that I would use to deal with services. Now, one thing that we did add, which helps with the scenario that we just saw in the video and what Vin was talking about, is the ability to create a Python UDF through a REST call as well. So much like the ability to deal with services, you can list Python UDFs in your database. You can create a new one, update it. You can describe the Python UDF, which is going to show you what the inputs and the outputs of that UDF are, and obviously you can delete them. Just because my environment right now, I have already taken a sample Python file. I had to put it onto my server just because of the nature of my work from home setup. I could have transferred it there automatically, but I can't right now. So let's just run the call to see what Python functions I have. And in my database, I don't have any at this point. I do not have an ML use case in my simple example. It's an absolutely trivial Python call that I'm making. It's doing subtraction. Clearly, there are more efficient ways of doing subtraction in DB2 than invoking Python. But by way of a demo, this is just a quick example of how I can do it. So this file I have saved on my database server. It is in a location that is accessible to my database. And much like what you saw when Vin showed the sample of how to run SQL to create a Python user-defined function, I can do the same thing for the REST call. We've removed all of the options that are not modifiable because they're basically hard-coded in that call. But as you can see from the Python that I have here, it accepts two parameters, x and y, and it returns a single integer. So I've defined two inputs, and I'm returning a single input, which is an integer. This is a scalar function that I'm using, or it could have been a tabular one if I'd wanted. There's also the ability to create an aggregate function. If I create aggregate functions, I have to identify the state parameters because there needs to be something that's going to store the data as each row is evaluated. So I'll create that Python function. So we now have a function. If I go up and run the query again for functions, we'll now see I have a Python function, and it's indicating where the Python file is on my server. I happen to be running a Db2 warehouse container on my Linux machine. But just like anything that I can put into a REST service, I can certainly use Python or any other UDF inside of the SQL that I want to execute. So I took that complicated SQL statement that we showed earlier for looking at overages, and I've basically created a new service where each records evaluation is going to run the Python code and basically do the math, which is, as we saw, simple subtraction. I now have a service for getting claim overage, and just like any service, I can execute that, and what I get back is the data. So the one thing that I didn't touch on, which I'll scroll back because I saw a question coming in chat about it, is that when I create services, the service is associated with a SQL statement, and that SQL statement is a select, insert, update, or a delete. So that is currently the functionality that is available for creating services, but I can also run SQL. So I think the question was, can I run create table or drop table? And the answer to that question is yes, because you can invoke SQL. You just can't put a create or a drop table statement inside of the service. And just like the ability to run SQL using the create SQL endpoint, you could also invoke a stored procedure, whether that stored procedure takes import or not. But like create and drop, those are not available in service calls at the moment, and it may be something that we work on in the future. So I'm going to end my bit of demo here. and pass the screen back to Tom, who is going to show something more interesting than a Jupyter notebook, because Tom has a live demo where he shows how to build a real application using these endpoints. So let me stop there, and I'll send it back to you.
Thanks, Dan. And now, before Tom can start, we have another poll. So this question is about what's most important for you as a developer. And if you don't see the options in this list, please feel free to put your comments on the Q&A box.
So I'm really excited about Tom's demo, because as a developer, it's not what tools are available, but what you can actually do with those tools. And that's where the real innovation starts. So kind of bringing in new ideas and building something with the tools is what's exciting to me, or a useful set to me as a developer for sure. So let's hope that, Tom, you have fully loaded deck coming up.
Okay, so we've finished our poll. Tom, you can begin.
Thanks, Shruti. Let me share my screen. All right, so we just saw a fantastic demo from Dan about Db2 REST. Now we're going to talk about, well, so we have all these great tools, but what can we do with them? Well, one option is we can integrate Db2 with mobile technology. So today, more and more people are demanding mobile-first experiences, and it's not just consumers. The enterprise world wants this too. Advances in Db2 tooling have opened the door for a tighter integration between mobile devices and Db2. So we could take the benefits of the data management console and REST services and create a mobile-first experience that can benefit anyone who interacts with data. This could be voice-initiated questions about Db2 health, on-demand query visualizations, push notifications for database alerts, or when data changes. So a couple quick examples. Database administrators will be able to call DMC APIs to ask health or metric-related questions, as well as subscribe to get alerts if DMC detects a problem. And data consumers can make use of Db2 REST services to either display query results or subscribe to push notifications when the data changes and meets conditions that they're interested in. So we have demos that we're going to show as well for all this, but just quickly, visualizations through Db2 REST. You can create a service that returns data in a chart format and then assign it to a voice shortcut in iOS. So an example here, if I was in a support manager or development manager, and I can say, give me all my defects sorted by date, an account of them. I want to watch a weekly trend of my defects, and then assign that as a shortcut that says, hey Siri, how is my defect backlog? And then I get a nice chart right in Siri's interface showing my product's defect backlog. It's also not only asking questions, but what if you wanted to be notified when your data changes and meets certain criteria? So recurring tasks with Db2 Assistant will allow you to enable push notifications for any application that stores data in Db2. You could create a task that uses a SQL expression as a condition, which would get created as a Db2 REST service under the hood, and then you define a schedule to run that service on. And then finally, using the low-code interface builder, you can build up what the phone UI will look like when the push notification comes in. So you could use some text like the latest results are ready. You could use a previously created visualization, display a chart, or if your result set's going to return multiple rows, you can return a list in the phone. You can also extract column names used from the Db2 REST service and use those as variables, allowing for dynamic output. So you can have something that says you have a count of your results ready for review. And then the APIs through Data Management Console can allow you to query the health of your database on demand. So you can ask questions like, how's my database performing, or how's my database hardware? And then database administrators can also subscribe to alerts for the profiles they have access to in DMC that says, hey, DMC has detected a problem, and you can get a push alert right on your phone. Here's a couple of use cases before we get to a demo. So as I mentioned, database administrators can get notified of problems right on their phone, or they could just check the health of their database whenever they want. If you're in support operations, you can create recurring tasks to be notified if your support NPS drops, your defect backlog increases, or new escalations come in. You can also run on-demand visualizations to understand the health of your product. And anyone who uses data could benefit from this. So you're a data scientist, and you could set up a task to get notified when the latest ML results in DB2 have finished processing. Or if you run your own internal root certificate authority, you can get push notifications when your SSL certificate is about to expire. Anything that's stored in DB2 is good for this. So we have a quick demo here that we'll go through. And actually, I think I need to just switch the way that I'm sharing to allow the computer audio to work. Sorry, 1 second. All right. One of the panelists can let me know if the audio is not coming through.
Not yet.
Not yet. Okay. 1 second. Nothing like some WebEx problems. I will just try sharing this a different way. Okay, it doesn't look like that is letting me share it with the audio that way either.
Tom, the audio might come through if you take off your headphones.
Okay, let me try that. Give me 1 second. I have to switch the audio connection with WebEx as well.
Or we have this on YouTube.
The Db2 Assistant app will bring the power of Db2 directly to your mobile device. It can interact with the IBM Db2 Data Management Console to retrieve health and metric-related information about your database. For example, hey Siri, how is my database performing?
Okay, requesting. In the last hour, there were 30 connections executing 1.4 thousand queries, which have accessed 930.1 thousand rows. It took Db2 an average of under 1 second to process each query.
Hey Siri, how is my database hardware?
Okay, requesting. In the last hour, CPU use averaged 1% and memory use averaged 58%. Database storage is using 70% of available space, while logs are using 1% of available space.
It can also run Db2 REST services, allowing you to query Db2 directly from your phone. For example, hey Siri, what is my defect backlog?
Okay, requesting. Project has a current effect backlog of 658.
We're not limited to just asking questions either. Using recurring tasks, which is a feature of Db2 Assistant, we can create Db2 REST services to run on a schedule scanning our database. Whenever the data changes and meets certain conditions, we can send a push notification to any user who has subscribed to that change. This will allow any application that stores its data in Db2 to send push notifications. Here, a push notification just came in saying that our latest fraud detection results are available. Db2 has finished running our fraud detection machine learning models against the latest health insurance claims filed and has identified 10 of them as being suspicious. Recurring tasks uses a low-code interface allowing you to build what the phone UI will look like. In this case, when we click Open Results, we've defined that the button should be a share target. The user can share it to their laptop, log into their Jupyter notebook, and start analyzing right away. This is the power of Db2. It connects everything in one spot for you. Using Db2 Assistant, Db2 REST, and DMC, you have the entire power of your database right at your fingertips.
Okay, and that's the whole demo. I'll turn it back over to you, Vinik.
Thanks a lot, Tom. So, Shruti, that brings us to the last poll question, and after that, we will do some Q&A.
Okay, so yeah, the polls are open. While you're all answering the poll, I think we can go to Q&A. So I did see a lot of questions about documentation and where these samples might be available. And I guess there was a lot of interest in both Tom's demo as well as Dan's demo. So are these going to be available to users and when?
Dan, do you want to talk about the REST notebook that you are going to publish?
The documentation is going to be all available at the end of the month, as been already mentioned. What you'll see when you look at the documentation is basically a walkthrough of using all of the endpoints. So it's more extensive than what I put into the Jupyter notebook. Of course, we can talk about sharing that notebook as well. It's not part of the documentation set at this point, but all of the content is available on the in the documentation site for Db2.
Okay. There's a question on REST APIs. So is the REST API an update of the previous gateway for OData, or is this an entirely new process?
This is entirely new. So it's a brand new server. It's actually implemented in Go using the Go driver.
Okay. And another question on REST. Does it also allow to run any utilities as well as run stats, load, etc. to the application users or DBAs, or is it just DML for now?
You can only run DML.
Okay.
Well, you could run DDL as well, but you can only run something that is executable through the driver connection.
Okay. So do we plan to support the ability to execute stored procedures via REST?
You can run a stored procedure right now, as I mentioned, using the as XSQL call. And we're having conversations about what might be next for extending the capabilities of the service creation as well.
Okay. And there's a question on the Python UDF. Are we feeding the model to Db2 database through this Python UDF? So I'll just read out Vin's answer, and if he wants to elaborate, he can interrupt me. If you are talking about back scoring, then yes. If you're referring to training the model, then it has to be done outside, as it requires multiple iterations, which is not practical to do inside the database.
Yeah, so I think the question was, probably I didn't get the complete question. The question was, are we feeding the model to Db2 DB to the Python UDF? Now, using the Python UDF, you can implement a Python script, which can be about using a pre-trained model in Python and use that script to batch score, which was shown in the demo. But if the question is around training the model itself to create a trained model for a specific use case, then in practice, developing that requires multiple iterations, and kind of a pre-packaged UDF would not be the best approach to do so, which was also shown in the demo, that using the Jupyter notebook finalizing the trained model and then using that for batch scoring would be the best practical use.
Okay, so we are at the top of the hour, so I think we'll end the Q&A here. If you have any more questions or suggestions for future sessions that you want us to do, please let us know either in this Q&A box or send us a note to the Db2 community newsletter or the email you have.
Thanks a lot, everyone.